Breakthrough: Socially Assistive Robot Helps Children with Autism Learn. I'm Steve Blair. Welcome to Breakthroughs. USC researchers developed personalized learning robots for children with autism and studied whether the robots could autonomously gauge the child's engagement in long-term in-home therapeutic interventions. Many children with autism face developmental delays, including communication and behavioral challenges, and difficulties with social interaction. This makes learning new skills a major challenge, especially in traditional school environments. Previous research suggests socially assistive robots can help children with autism learn. But these therapeutic interventions work best if the robot can accurately interpret the child's behavior and react appropriately. Now researchers at USC's Department of Computer Science have developed personalized learning robots for children with autism. They also studied whether robots could estimate a child's interest in a task using machine learning. In one of the largest studies of its kind, the researchers placed a socially assistive robot in the homes of 17 children with autism for 1 month. The robots personalized their instructions and feedback to each child's unique learning patterns during the interventions. After the study was completed, the researchers also analyzed 7 other participants' engagement and determined the robots could have autonomously detected whether or not the child was engaged with 90% accuracy. The results of the experiments were published in the Frontiers of Robotics and AI and Science Robotics journals on November 6th and February 27th, respectively. Robots are limited in their ability to autonomously recognize and respond to behavioral clues, especially in atypical users and real-world environments. This study is the first to model the learning patterns and engagement of children with autism in a long-term in-home setting. Current robotic systems are very rigid, said lead author Shomik Wan, a progressive degree mathematics student. If you think of a real learning environment, the teacher is going to learn things from the child and the child will learn things from them. It's a bidirectional process, and that doesn't happen with current robotic systems. This study aims to make robots smarter by understanding the child's behavior and responding to it in real time. The researchers stressed the goal is to augment human therapy, not replace it. Human therapists are crucial, but they may not always be available or affordable for families, said Kartik Mahajan. That's where socially assistive robots like this come in. The research team placed Kiwi the robot in homes of 17 children with autism spectrum disorders for about a month. The child participants were aged between 3 and 7 and from the greater Los Angeles area. During almost daily interventions, the children played space-themed math games on the tablet, while Kiwi, a 2-foot robot dressed like a green-feathered bird, provided instructions and feedback. Kiwi's feedback and the game's difficulty were personalized in real time according to each child's unique learning patterns. Matrix's team in the USC Interaction Lab accomplished this using reinforcement learning, a rapidly growing subfield of artificial intelligence. The algorithms monitored the child's performance on the math games. For instance, if a child answered correctly, Kiwi would say something like, "Good job." If they got the question wrong, Kiwi might give them some helpful hints to solve the problem and adjust the difficulty and feedback in future games. The goal was to maximize difficulty while not pushing the learner to make too many mistakes. If you have no idea what the child's ability level is, you just throw a bunch of varying problems at them, and it's not good for their engagement or learning, said Wan. But if the robot is able to find an appropriate level of difficulty for the problems, then they can really enhance the learning experience. There's a popular saying among people with autism and their families: if you've met one person with autism, you've met one person with autism. Autism is an ultimate frontier for robotic personalization because, as anyone who knows about autism will tell you, every individual has a constellation of symptoms and different severities of each symptom. This presents a particular challenge for machine learning, which usually relies on spotting consistent patterns of huge amounts of similar data. That's why personalization is so important. If we take a cue from a child, we can achieve so much more than just following a script, said Meteoric. Normal AI approaches fail with autism. AI methods require a lot of similar data, and that just isn't possible with autism, where heterogeneity reigns. The researchers tackled this problem in their analysis of children's engagement after the intervention. Computer models of engagement were developed by combining many types of data, including eye gaze and head pose, audio pitch and frequency, and performance of the task. Making these algorithms work in real-time data presented a major challenge, given the accompanying noise and unpredictability. This experiment was right in the center of their learning experience, said Cartet. There were cats jumping on the robot, a blender going off in the kitchen, and people coming in and out of the room. As such, the machine learning algorithms had to be sophisticated enough to focus on pertinent information related to the therapy session and dismiss environmental noise. Assessments were conducted before and after the month-long interventions. While the researchers expected to see some improvements in participants, the results surpassed their expectations. At the end of the month's intervention, 100% of the participants demonstrated improved math skills, while 92% also improved in social skills. In post-experiment analysis, the researchers were also able to glean some other interesting information from the data that could give us a peek into the recipe for ideal child-robot interactions. The study observed higher engagement for all participants shortly after the robot had spoken. Specifically, participants were engaged about 70% of the time when the robot had spoken in the previous minute, but less than 50% of the time when the robot had not spoken for more than a minute. While a personalized model for every user is ideal, the researchers also determined it was possible to achieve adequate results using engagement models trained on data from other users. Moreover, the study observed caregivers only had to intervene when the child lost interest for a long period of time. In contrast, participants usually re-engaged by themselves after shorter periods of disinterest. This suggests robotic systems should focus on counteracting longer periods of disengagement. Wow, that's cool. I'll leave a link in the description to the full article, and as usual, please like, share, subscribe, and take care.